Hello everyone, this is a quick update about synthesis-free approach. Based on our design flow, we have several steps to do that, and today I've given you a quick demo to show you how it works. Let's jump into the code. Here's a typical H-thread code. In our threads, assume we have a program is doing dot product, and a software programmer want to accelerate this. So I will show you a type of DSL. I created this version of the DSL is like the functional design. And each module we call that functors. And the same thing is doing the dot product. First is doing the vector multiplication, and the results goes into the reduce module, and we have the results. So this is a DSL to design this dot product accelerator. And how can we run it? So first we have to compile the code for the DSL actually. So we call that VAM compile. So after we compile it, so the VAM compile will translate this DSL description to VAM calls. So here is a VAM calls. So this is a file after we compile it. So originally the design is a comment, but it's replaced by the several of VAM calls. And this VAM calls is controlled our virtual accelerator machine to run it. Actually, this is a static VAM call. During the runtime, we will doing the runtime interpretation to run it. And let's run it first to try this correct. So after we embedded the VAM calls, and we have to go through the typical H-thread program flow, and to compile the code and link the VAM calls with the hardware information into it, and then generate the bitstream we downloaded. Since the executable file include the partial reconfiguration bitstreams, so the download speed is a little slow. I mean, it takes some time. Okay, the time it's showing up and it's passed. So this is a dot production. Okay. So this is our design. So for example, so later the software designer changed his idea and to give us a new design. This is a new design doing the vector multiplication first, and then doing the addition, and then do the reduce. So this is a new design. So here, and this is probably the checking part. So let's save it and run it. So normally this is a new accelerator. The typical design flow is you have to resynthesize the whole program, but right now I will show you how fast you can change the design. So first we compile the DSL. Okay, so VAM calls has already embedded into the source code, and then we compile the source code to go through the typical H-thread program flow, and then download it. And on the left side is the UART output from the FPGA board, and I keep the output from previous application. As a contract, you can see the difference. Okay, it's passed. And based on the value, we know that, so these are two different applications, and we just change the design, and we design our new accelerator, but without go through the typical hardware synthesis process. So you see how fast it can be to change your accelerator. Okay, that's it. So this is our rep 1, and we use this really naive and simple DSL language. So right now for rep 2, our team is working so hard to design a new DSL based on the D-Lite the compilation framework. So just stay tuned, waiting to our next episode.